Hello guys, welcome once more to GCE Math Panel, working together with Math Super Channel 24. And in this particular tutorial, which is preparations for GCE A level, we are looking at chapter 4, an introduction to polynomials. This chapter is made up of 4 sub-lessons, which are introduction, then we have the remainder theorem, the factor theorem, and identities. Please make sure that you follow this lesson to the end, and don't forget to click on the subscription button if you have not subscribed, to leave your comments, to share, and as well to participate. You can equally get past questions from our blog. Just go to Google and type GCE Math Panel and type your level. You are going to find any past questions you are looking for. Please follow this lesson to the end, and at the end, make sure you solve as well. Thank you and stay tuned. So in the first place, we'll start by looking at what is a polynomial. What is a polynomial? Monomials are one-term expressions. Expressions with 2 terms are binomials, while those with 3 terms are trinomials. Generally, polynomials refer to more than one term expression. Let's look at some examples. For monomials, which are one-term expressions, we have, for example, 3x squared. We equally have 2x. Recall that nomials refers to the number of terms. Nomials, number of terms. So an expression in one term is a monomial. Expression with 2 terms, binomial. 3 terms, trinomials, and polynomials. In fact, from 2 terms and above, we have a polynomial. Now with binomials, which are 2 terms examples, we have example x squared minus 4x. We currently have 3x minus 4. All these terms have 2 terms, or all these expressions have 2 terms. You must have probably heard about binomial expansion. And then you equally have trinomials. Trinomials are 3-term expressions. For example, 2x squared plus 3x minus 2. And what are polynomials? Polynomials are expressions with more than one term. There are many term expressions. Let us look at this very important remark. All polynomials must have positive whole number as exponents. If the whole number is not positively whole, then it is not a polynomial. For example, 9x to the power minus 1 plus 12x to the power a half is not a polynomial. Why? Minus 1 is not a positive exponent, and a half is not a whole number. So you must be warned and take note of this. Let's take an example. Fill in the table below. We want to do some sort of a classification. So we have the following values. We have 9, 4x, x squared, all of that, up to 4x squared minus 9x plus 2. We want you to tell us the number of terms, that is nomials, and to classify it whether it is mono, bino, trino, or polyno. So the first one has just 1 term. Number of terms is 1, so it's a monomial. The second one has how many terms? 1 term. It's also a monomial. The third one has 2 terms, 2, so it's a binomial. Do not get confused between binomial and square. We are going to look at degree in the next subheading. This other one has, that's number 4, has 3 terms, so it's a trinomial. Then for number 5, it has 4 terms, 4 term expressions, so it's a polynomial. The 5th one has 3 terms, it's a trinomial. So this is the classification, and this is very, very important. Now let's look at the degree of a polynomial, the degree of a polynomial. The degree of a polynomial is the highest power to which its variable is raised. The term that contains the largest sum of exponents. So it can equally be attributed to the term with the largest sum of exponents. We are going to see this in one of the examples, why this definition is given. Normally, constant terms have a degree of 0. For example, 2 is a constant. The degree of 2 is 0. Why? It has no variable. Or it's a term without a variable. All right. So polynomials with degrees 1, 2, 3, and 4 respectively are classified as linear, quadratic, cubic, and quartic. Polynomials with degrees 1, 2, 3, and 4 respectively linear, quadratic, cubic, and quartic. You have seen all of these equations now, like quadratic equations, you know them. Linear equations, you know them. Cubic equations, you have seen them. Maybe quartic equations and higher order equations are a bit unfamiliar. Now let's take an example. Fill in the table below. We are going to use the same table that we used previously, but this time we are concerned with the degree of the polynomial that has been given. So we have the following. So the first one, we have 9. 9 is a constant, so the degree is 0. All constants have a degree of 0. So the constant, and when it's a constant, it is classified as a constant. Or when the degree is 0, it's classified as a constant. Now this second term, there is just one term, but you can see x here, and the x is to the power 1, though you cannot see the 1. Any number raised to the power 1 is the same number, so the power here is 1. The degree just means the power, the highest power of the variable. So the degree, the power here is 1, the degree is linear. With this, it is also linear. The degree, or the power rather, is 1, so the degree is 1. It is linear, but it has two terms. It's a binomial, but it's linear. This next one, it has, the highest power here is 2. So the degree is 2, and we say it's quadratic. Quadratic means the degree is 2. With this other one, the highest power is 3. So the degree is 3, and we say it is cubic. The next one, the highest power is 4. The degree is 4, and we say it is quartic. What if it is 5? Let's take this very important remark. Take note that if a term has more than one variable, the degree is a sum of exponents of the products of that variable. This one now comes into play with this indication in red. The term that contains the largest sum of exponents is referring to this one. So when we have an expression with multiple terms or multiple variables, like a term in xy, a term in yz, and so on, this is how we get the degree for that one. This x squared y cubed is a product, so the degree here is 2 plus 3. Here x to the power 5, y to the power 2. The degree here is 5 plus 2, and the degree here is just 4. So the highest degree, or the degree of this polynomial here, is 7, because we need the degree of x and that of y for the same term, and that degree is equal to 5 plus 2. That gives us 7. So be careful with this. Normally, these are university examples, or you can see some of these also in further maths, and you will still meet these things in higher studies. We next look at adding, subtracting, multiplying, and dividing polynomials. Normally, poly divided by poly is equal to poly. Poly times poly is equal to poly. Poly plus poly is equal to poly, and poly minus poly is equal to poly. But we want to focus on these first three, to add, subtract, and multiply polynomials. There is a special property that division has, which we are going to look at. So to add and subtract polynomials, we add or subtract corresponding entries or terms, and multiplication is just by simply expanding. The results of these expressions or operations are also polynomials. For multiplication, we multiply each term in one polynomial by all the terms in the other polynomial, and then we simplify. Let's take this example. Simplify the following. So let's start with addition. We have 4x squared minus 9x plus 2. That's the first polynomial. Plus the second, which is 5 minus 8x minus x cubed. So we are going to do this addition term by term. Terms in x cubed is just this one. So we have minus x cubed. Terms in x squared, you have just this plus 4x squared. Terms in x, you have minus 9x minus 8x, which is minus 17x. And constant terms, you have 2 plus 5, which is 7. Then equally, we have Subtracting polynomial. For subtraction, we are going to have 5 minus 8x minus x cubed. That's the first polynomial. Minus 4x squared minus 9x plus 2. So this poly minus this other poly. Now the terms in x cubed, we have just minus x cubed minus 0, which is minus x cubed. Then we have minus 4x squared, because that's the only term in x squared. Then the terms in x, you have minus 8x minus 9x, which is 1x, as you can see here. And then 5 minus 2 is 3. That's for subtraction of polynomials. Let's take the case now of multiplying polynomials. So if we multiply this polynomial by this, we are multiplying term by term, as we said. So we will take the first term in the first polynomial and multiply each of the terms in the second polynomial by this. So we have 5 times all of this polynomial minus 8 times all of this polynomial minus x squared times all of this polynomial. We now expand and simplify. And these are the results that we are going to have. So here, we can bring these like terms together. We first start by the terms in x to the power 4. There's just one. So you have minus 4x to the power 4. Then the terms in x cubed, we have 2 of them that are in yellow. Minus 32x cubed plus 9x cubed. That gives us minus 23x cubed. The terms in x squared, they are in red. We have plus 90x squared. And the terms in x, they are in green. As you can see, we have minus 61x plus 10. So for multiplication of polynomials, we just multiply all the terms in the second polynomial by each of the terms in the first polynomial. This is just like the reverse of quadratic factorization, which we have earlier seen in chapter 2. You advise equally that you can equally go back and look at chapters 1, 2, and 3 before you come back to chapter 4. Our next chapter will be on functions, and it'll be very, very important that you look at this chapter. After this lesson, we have factor and remainder theorems and identities. Don't forget to share this video and to subscribe. Now let's look at division of polynomials. We first of all have to note that dividend divided by divisor equals quotient plus a remainder. Dividend divided by divisor equals quotient plus a remainder. Let's take, for example, 19 divided by 7, which gives us 2 remainder, 5. So this is a 19 here. We divide this 19 by 7. We are going to have 19 divided by 7, that it goes 2 times. 2 times 7 is 14. 19 minus 14 is 5. So when we subtract, we have 5. So this gives us, this is the dividend divided by the divisor. That gives us a quotient and a remainder. So dividend divided by divisor is equal to quotient plus remainder. You can sing it as a song if you want. Dividend divided by divisor is equal to quotient plus remainder. A remark: at times you are asked to look for this dividend. In past questions, we are going to see this in one of the questions. Past questions at times require us to look for the dividend. They'll give students the quotient and give them the divisor and the remainder and ask for the dividend. Recall, for me to look for this dividend, this is the rule I must follow. It must be quotient times divisor plus remainder. So you can go anti-clockwise like this. Quotient times divisor plus remainder. That is BODMAS. So this can be written as 19 is equal to 2 times 7 plus 5. If the remainder is minus 5, we'll put plus minus 5 or just minus 5. So you go anti-clockwise. 2 times 7 plus 5 will give us this 19. So we can write that dividend is equal to, this dividend is equal to quotient times divisor in brackets, as we do that first, now plus a remainder. So take note of this. We are going to be applying this for division of polynomials. This is the concept. Nothing changes. And not if you divide and the remainder is 0, then it therefore means you have divided by a factor. For example, 6 divided by 2 is 3. The remainder is 0. Why? Because 2 is a factor of 6. So whenever you divide the number by a factor of that number, the remainder is 0. And that is what we discussed in the factor and the remainder theorems, which we are going to see shortly. So normally division of polynomials follows long division. Therefore, the polynomials f of x, g of x, h of x, and r of x can be written in the same way as you have seen previously as follows. So if you have f of x divided by g of x, that is going to be equal to h of x plus a remainder. F of x divided by g of x is equal to h of x plus a remainder, such that if you are to solve for f of x, that will be equal to g of x times h of x, or h of x times g of x, since the operation is commutative, plus r of x. Let's take some beautiful examples. Example 1. Divide the polynomial 2x squared by x squared minus 1 and state the quotient and the remainder. Note that we are using long division. So we divide this and state the quotient and the remainder. So this long division is all set. Now, 2x squared divided by x squared. That will give us 2. Now, this 2 times x squared is 2x squared. And 2 times minus 1 is minus 2. We now subtract. The subtraction sign is here, though it's not written. You can decide to write it, but you have to put this in brackets. So we now subtract 2x squared minus 2x squared. That will give us 0. And then 0, we don't need to write the 0. 0 minus, this minus sign that is hiding here. 0 minus minus 2 is plus 2. We have seen this in the previous lesson of partial fractions, the type 4. In which case we had the quotient of the numerator is greater than or equals that of the denominator, right? Yeah. So our dividend here is 2x squared. Our divisor is x squared minus 1. Our quotient is this 2. And our remainder is 2. So Q of x is 2 and R of x is 2. A second example. So let's divide that by that and state the quotient and the remainder. So we go by long division. X squared divided by x squared gives us 1. 1 times all of these divisor will give us x squared minus 3x plus 2. Now we subtract x squared minus x squared, 0. 0 minus minus 3 is 3x. And 0 minus plus 2 is minus 2. Now this degree is less than this degree here. The degree of the remainder is less than that of the divisor. So we don't have to continue. So here, our quotient Q of x is 1. And our remainder R of x is 3x minus 2. That is the remainder. If there is something you don't understand, watch the video over again. Move to the block, the notes are there. Click on notes and then you'll see all of these notes exactly as you see them on screen here. Don't forget to subscribe and to share this with your friends. And secondly, mathematics, drill and practice. What you have to do is, after this, solve all of these questions again. That is when you have studied. If you are just watching, you are just reading. You can get past questions from www.gcemathspanel.blogspot.com. Example number 3. Find the quotients and remainder when f of x equals 2x cubed minus 3x squared minus 11x plus 6 is divided by x plus 2. Hence, factorize f of x completely. Whenever they say factorize completely, they want that your answer should be as a product of linear factors. We have seen what is meant by linear in the previous lesson. So let's proceed by long division. Now we have 2x cubed divided by x. That gives us 2x squared. 2x squared times x gives us 2x cubed. 2x squared times plus 2 gives us plus 4x squared. We now subtract. The minus sign is here as we know. 2x squared, 2x cubed minus 2x cubed is 0. Minus 3x squared minus 4x squared is minus 7x squared. We bring down these terms. Then minus 7x squared divided by x is minus 7x. Minus 7x times x is minus 7x squared. Minus 7x times 2 is minus 14x. We subtract again. When we subtract, we are going to have minus 11x minus minus 14x is plus 3x. We bring down this plus 6. Now, plus 3x divided by x, that gives us plus 3. Plus 3 times x is plus 3x. Plus 3 times 2 is plus 6. When we subtract, the remainder is 0. When the remainder is 0, what does this tell us? Means that we have this, means that this x plus 2 is a factor of this dividend, it's a factor of this number. For example, when you divide 6 by 2, you have 3 remainder 0. Why? Because 2 is a factor of 6. So this x plus 2 is a factor. And since it's a factor, we can therefore write our f of x as a product of this and this. That's of the dividend and the quotient. Right, of the divisor and the quotient. So f of x can be written like this. But this is a quadratic and it can be factorized. So if you factorize this, we will now have, let me cancel it. So here we have to look for two numbers that when we multiply, we'll have 2 times 3 is 6. That when we multiply, we'll have 6. And when we add them, we'll have minus 7. Those two numbers are minus 6 and minus 1. If you don't understand this concept, look at chapter 2, factorization of quadratic equations. You will see all of this that's well explained. So we are going on from there. So plus this, now pair them, now group them in twos and factorize. Here we have 2x, the highest common factor is x. So 2x into x minus 3, and with this one I have minus 1 into x minus 3. Now x minus 3 is common, so we factor it out. Then we are left with 2x minus 1. What is outside, we now put in another bracket. So we can now write this our expression as x plus 2 times the product of these factors. So this gives us x minus 3 into 2x minus 1, then times this last factor here, which is x plus 2. Yes, this is a sweet example. I like it so much. Example 4, given that h of x equals that is divided by x minus 2, find the quotient and remainder. B, hence, if f of x equals h of x plus 1, then factorize f of x completely. Hence, solve the equation f of x equals 0. I want to emphasize that whenever you hear the word hence, it means you must continue with the solution of the previous sub-question. For example, I've solved A here, and I'm now in B. They say hence, means I must continue with the solution. I have the previous question. Or I must continue with the previous question, the working there to have the final solution. That is hence. If they say hence and otherwise, you have a choice. But if they say hence, you must follow instructions. Hence means you must continue. They're not begging you. You don't have a choice. Hence or otherwise means if you like, continue. If you like, use a different method. So be very careful with hence. Even the C part C has hence. So I must continue with the solution in B. Good. That's understood. So let's do our long division. We have 2x cubed plus 7x squared minus 7x minus 31 divided by x minus 2. So 2x cubed divided by x gives us 2x squared. 2x squared times x gives us 2x cubed. 2x squared times minus 2 is minus 4x squared. We subtract. 2x cubed minus 2x cubed is 0. 7x squared minus 4x squared is 11x squared. We bring down these terms. Now 11x squared divided by x is plus 11x. Plus 11x times x is plus 11x squared. 11x times minus 2 is minus 22x. We subtract again. 11x squared minus 11x squared is 0. Minus 7x minus 22x is plus 15x. And we bring down minus 31. Now 15x divided by x is plus 15. So 15 times x is plus 15x. 15 times minus 2 is minus 30. When we subtract, the remainder is minus 1. Minus 1 tells us that this one is not a factor of this one, right? So that's our A. Now for B, they say if f of x is equal to h of x plus 1, factorize f of x. The first thing you have to do is to look for f of x. So our quotient and remainder are this and this. This is the quotient, this is the remainder. So h of x is equal to, since this is h of x we have been working with, is equal to this times this plus this remainder. So it's x minus 2 times the quotient plus the remainder, which is minus 1. For us to have our f of x, we have to say this h of x plus 1. If you add plus 1 here, we'll just be left with only these two brackets, which when factorized, this is the final result that we'll have. As a product of 3 linear factors, this is what we will have. And why do we have it in this form? Let me explain this way. This is because this is a quadratic, and when you factorize, this is what we will have. Equally, the last part says that hence solve the equation f of x equals 0. For us to solve this, we just equate each of these factors to 0 and solve for x. The first one, x minus 2 equals 0 implies x is equal to 2. Second one, x is minus 5 on 2, and the third, x is minus 3. Guys, you have to take note of this particular question because it's a past question, and most past questions resemble this one. They just modify them every year. The things actually do not change, they just modify. So study of the GCE should be done in a qualitative way. You have to study smartly. Don't spend all of your time reading. Reading is not important with A level. You have to spend most of your time thinking and answering questions. If you don't answer questions, you are not ready for the A levels. You are not. That is the key. Because somebody who is reading and somebody who is only answering questions, the person that is only answering questions is far better than the person that is reading, because the person has gained question answering skills. And with the GCE, they want the question answering skills. If you have the knowledge and you cannot write it down, you will fail and carry your legs up. And only God knows what people will see when you carry your legs up. All right, sorry that I'm being a bit far from this. Stay tuned, and this has been the GCE Math panel. Don't forget to subscribe. Our next lesson is on the remainder theorem. Don't forget to go to our blog and to get past papers. Don't forget to go there and take the quizzes. The notes and everything we do here, they're on that blog. GCE Math panel for life, the citadel of mathematics. Thanks to Math 24 Super Channel, which we are all working together. God bless the mathematics family.